Okay, how to use the F table. So the F distribution table is needed in this course for a number of different tests and methods. Here's our formula sheet. And the first time we saw the F distribution was right here. It was a hypothesis test for the difference of two variances. So the null hypothesis was the difference between two variances was equal to 0 versus they were not equal to 0. So another way of putting that together is the null hypothesis is the variances are equal versus the alternative hypothesis is the variances are not equal. And that is when we needed that F test statistic, which was equal to the larger sample variance divided by the smaller sample variance. And we get the degrees of freedom in that order too. The numerator would correspond to the larger sample variance. So the size of the larger sample variance population, subtract 1, and the denominator would be the smaller sample variance sample size, subtract 1. Right, so we use it for that test. We use it for the analysis of variance or ANOVA, the randomized block design. We also use it for regression. So simple linear regression, and also multiple linear regression when we do the overall F test. So the overall F test requires the F test statistic, which you can see here can be calculated 3 different ways, and it depends on what you have, what you already have. So you calculate the F test statistic, and then you go to the table. So quite a few times we need the F table. And here's the F table that we use. We use always for the F distribution table, we always use alpha of 0.05 or 5%. And that corresponds to the area under the curve, which is 5%. And we want to find the critical value, the table value from this table, and it's going to line right up with that point where the shaded region starts. So let's suppose our numerator degree of freedom, or our first degree of freedom number, is going to be across the top here. You want to always do it in this order. So numerator, the first number is always across the top. And let's say that's 6 degrees of freedom. And then our denominator is along the side here. So it's going to be a row. And let's suppose it is 16. So then we cross tabulate 6 and 16, and we get 2.74. So this would be a critical value for 6 and 16 degrees of freedom. And that critical value would line right up with that point. And so if the F test statistic from our formula sheet, depending on what we're doing, what test we're doing, or what method, if it's regression or ANOVA, or if the test statistic is greater than the critical value, then that means it's in our rejection region, it's in the shaded region, and we would reject the null hypothesis and accept the alternative hypothesis, right? So that would be the critical value right there. And so if the F test statistic is not greater than the critical value, then that means that we cannot reject the null hypothesis. Okay, so whenever we do reject the null hypothesis, we automatically have statistical significance. And that means that the F test statistic is in the shaded region and it would have an area under the curve less than 5%. And so that would mean we have the result of the test is statistically significant. If the test statistic is not greater than the critical value, then it's not in the shaded region. It has a p-value greater than 5%. And our decision rule is consistent with that. And so we cannot reject the null hypothesis. And therefore, the test is not statistically significant. And that decision is the same for no matter what test you're doing. It's always the same.